So in this video, we're going to be looking at a Putnam problem. And the Putnam exam is a really difficult maths exam set by undergraduate students in North America. It's regarded as one of the most difficult maths exams in the world. So we're going to give a go at an integral from that problem. And it looks challenging, but it can be done with a really simple technique. So it's this problem right here. And it's 1 over 1 plus tan to the n x dx. Now, it's between 0 and pi over 2. Let's think about this. So, can we make a substitution? Well, if I say, could we do u equals tan x? Well, we'll end up with the sec squared term for our du or dt. It doesn't really work. We can't really do any partial fractions. There's no algebraic way. We couldn't do a trig sub. Not a lot you could do. You could try a virus substitution or a t substitution, like t equals tan x by 2, but it also doesn't really work because of this awkward n. So we're going to use a tool called King's rule, or a reflection substitution. And King's rule, or a reflection substitution, I'll write it over here, is that the integral between b and a of some function is the same as the integral between b and a of the function a plus b minus x dx. So that's a pretty useful result. So let's give that a go. Let's see what happens. So that means we'll have I is equal to the integral between pi over 2 and 0 of 1 over 1 plus tan to the n of pi over 2 plus 0 minus x. And that's really good. Let's have a look. Well, that is an identity that we know. So tan of pi over 2 minus x is cotangent by the cotangent or the cofunction identity. So that means we can write this, that I is this integral right here. 1 plus cot to the n of x dx. So we can multiply top and bottom by tan to the nx. This is looking much more promising. Apologies, shouldn't be another dx in there. Multiply that. And we get tan to the nx over 1 plus tan to the nx. Now, you might be wondering, why on earth would we do that? That looks worse. That looks way worse. We're going to do something weird. And what we're going to do is we're going to add this expression for I to this one. And we'll see what happens. So I plus I is just 2i. And that's going to be integral between pi over 2 and 0 of our original expression plus the one we just found up top. And that's going to be tan to the nx over 1 plus tan to the nx. And you'll see that just becomes 1. And it looks super easy, because it is. We just end up with this. The integral between 0 and pi over 2 of dx, which is just pi by 2. Now, that's 2i. So therefore, the integral is equal to pi by 4. So that was a challenging problem. There's not really any other techniques that we can do that solves that problem. But that's from Putnam exam, so that's a really nice way to solve that.